In this video, we're going to look at solving parallel circuits, simple parallel circuits where we have just two resistors or two light bulbs in parallel with each other. To be in parallel means that the wire splits and the two wires then run parallel, the two devices run parallel to each other. So you have multiple loops with a device on each loop. The first thing we do is the same as what we did with the series circuit in the previous video, is that we solve for the equivalent resistance. That is the total resistance seen by the battery. The problem is we don't just add them up. We don't just say 6 plus 6. Instead, what we do to get the inverse of the equivalent resistance, we add the inverse of each resistor. So in this case, we take 1/6 plus 1/6. If I type that in my calculator, I get 0.3 repeating. But that is not the equivalent resistance. The equivalent resistance is going to be the inverse of this value. So to get the equivalent resistance, I'm going to take 1 over 0.3 repeating, which comes out to be 3. Now, just like before, once we know two values, we solve for the third using Ohm's law. So here we have two values. We have the voltage is 12. We're solving for the current, and the resistance is 3. We get the current then to be 4 amperes. Now, in a series circuit, we said all the I's were the same because the word series has that letter I in the middle. On a parallel circuit, all the voltages are the same. And perhaps you can remember this if we look at the word parallel. It has these two L's in the middle. And those two L's almost make that V symbol. So the two L's kind of make the V symbol. So in a parallel circuit, all the V's are the same. That means if the battery is 12 volts, the voltage of the other resistors are also 12 volts. And again, once we know 2 out of the 3 values, we solve for the third using Ohm's law. Here we have 12 equals I times 6, and I comes out to be 2 amperes. And here we have the identical thing, 12 equals I times 6, and we get I to be 2 amperes. Now this next circuit, we're going to have a 6-volt battery, and it's hooked up to a 2 and a 4 ohm resistor in parallel. Again, there's these two loops. So what I'd like you to do is I'd like you to pause the video and solve for the equivalent resistance and the current supplied by the battery to start. Go ahead and pause the video. When you're ready, unpause and see how well you did. Okay, welcome back. Again, we're going to take the inverse of the equivalent is equal to 1 over 2 plus 1 over 4. This comes out to be 0.75. Again, that is not my equivalent resistance, though. The equivalent resistance is going to be the inverse of the 0.75, which comes out to be 1.3 repeating. I'll just round it off to 1.33 ohms. Now, once we know 2 out of the 3 values, we can solve for the third using Ohm's law. We have 6 equals I times 1.33, and we get I to be 4.5 amperes. Now what I'd like you to do is pause the video, solve for the voltage and the current of the other 2 resistors, and when you're ready, unpause the video, see how well you did. Welcome back. In a parallel circuit, we said that the voltages are the same. Just like in the parallel word, the two L's kind of make that V symbol. So here, since the voltage of the battery is 6, all the other voltages are also 6. And once you know 2 out of the 3, solve for the third using Ohm's law. This current comes out to be 3 amperes. Here we have 6 equals I times 4, and this current comes out to be 1.5 amperes. This next circuit, We have a 6-volt battery hooked up to two 8-ohm resistors, and I'd like you to solve the entire thing. So pause the video, solve for the voltage, current, resistance at each section, and then when you're ready, unpause and see how well you did. Welcome back. First thing we're going to do is solve for the equivalent resistance. We say 1 over the equivalent is 1 over 8 plus 1 over 8, and that gives us a value of 0.25. That is not the equivalent resistance, though. To get the equivalent, we take the inverse of that. We take 1 over 0.25, and that gets us 4. So our equivalent resistance is 4 ohms. Once we know 2 out of the 3 values, we solve for the third using Ohm's law. We have 6 equals I times 4. We get our I, or current, to be 1.5 amperes. And in a parallel circuit, we said that all the V's are the same. Again, the 2 L's kind of make that V symbol. So if the battery is 6 volts, then everything is 6 volts in a parallel circuit. And once you know 2 out of 3, you solve for the third value using Ohm's law. Here we have 6 equals I times 8. We get I to be 0.75 amperes. Here again, we have 6 equals I times 8. And we get I to be 0.75 amperes. So the two main differences between series and parallel circuits: in a parallel circuit, we add up the inverses, 1 over, and then we have to take 1 over that answer to get our equivalent resistance. And in a parallel circuit, all the V's are the same.